Algebra 2 students. So I am going to be recording for you lesson 18 today. I don't want to fall any further behind in our lessons, especially since I missed the first week back after Christmas break. But let me say, even though I'm recording at home, I do have two dogs here, one my own, one my daughter's. We have cats, as you can see, one of our cats, Winnie, sleeping in his little cat bed up there. And so I apologize in advance for any distractions because I also live in a house with people, my husband and daughter and son. So anyway, we will get into today's lesson, which is distance, lesson 18, distance. And remember that distance is equal to rate times time. And excuse me, there are three ways that we can tackle these problems. So if distance is equal to rate times times, then I could also, if I wanted to know rate, I could divide both sides by r, right? And then time would equal distance over rate. Sorry, I think I said rate. We'll do that one next. And then finally, if I want to solve for rate, I would divide by time. And now rate is distance over time. And so just keep that in mind when you are working with these problems. I want to make sure you can see all of them. You can, because depending on what the problem is asking for will depend on which of these we are going to use. And remember that distance can be 6 miles, it can be 4 feet, it can be 3 yards, right? It can be all those different things, and it tells us how far. Rate tells us how fast they're going, right? And the most common is miles per hour. And then time can be 2 hours, it can be 5 seconds, right? Time tells us how long. Okay, so hopefully that's a little review of distance, rate, and time. So we're gonna get into some examples. Okay. And this is all in the teacher's manual in the front section. So that can be helpful for you as well when working through these problems. We start off pretty easy, but they get more complicated. All right, so how long will it take to drive 270 miles at 60 miles per hour? Okay, so we have to ask ourselves on these problems, what am I looking for? And what do I already know? We have 270 miles, okay? So that's our distance, right? 60 miles per hour is our rate. And what they're asking for is how long, or the time, right? And we know that time in the three problems, I no longer have them up here because I needed the thing, is distance over rate. So in our case, then the time is our distance of 270 divided by 60 miles per hour. So in this case, it's 4.5 hours. Okay, easy enough. Like I said, these do get harder as we go. Let's do example 3. What was your average rate of travel if you drove 420 miles in 8 hours? Okay. So this time we have time and we have distance, right? And so we're looking for rate, and rate is distance over time. So we're simply going to have 420 over 8, which gives us 52.5 miles per hour. Hopefully that is pretty self-explanatory and there aren't any questions so far. All right. Now let's get into, I want to do a couple more that may be a little bit different. Okay, now I'm on the practice problems. So if you're following along in the teacher's manual at the front, I'm on the practice problems. I'm only going to go over 2 of them. I would recommend that you go through all of them if this concept is hard for you. Okay, I'm going to cover 3 and 5. Number 3 says Jeff drove 11 hours at 85 kilometers per hour. Okay, so this time we're not using miles per hour, we're using kilometers, and I want to know how far. So we're looking for distance, right? How far? Because our 11 hours is time, our 85 kilometers per hour is rate, and so we know then if we drove, and this is another way to set these problems up, okay? Drove 85 kilometers in 1 hour, right? Yeah, in 1 hour. And this is where those unit multipliers come in handy that we learned last week, because we now say, okay, where am I going to put hours? I need my hours to cancel. So I'm going to put my 11 hours here, and that's over where we make that 1. And now my hours cancel, and it's 85 times 11, which is 935 kilometers. Okay. Now, you could have also said, okay, well, we know that distance is rate times time, sorry. So we could have just said our rate was 85 and our time is 11, and obviously then that is 935. And that is true, and that's what we were doing when we started off, but I'm also showing you that sometimes we have to do it this way, and sometimes we don't, and either way is correct. We know a lot of times in math that there is more than one way to arrive at the correct answer, and that's the case here, and that's why I'm showing you both ways. So whatever makes most sense to you, please use when doing your homework this week. Homework is not, by the way, homework is not going to change. I'm going to step out for just a minute. Homework is not changing from the syllabus. So while I'm thinking of homework, so we're doing lesson 18. You will have 18A all, B evens, C is 1 through 13, 18 through 20, and D is all. Okay. All right. So again, I did not change it from the syllabus. So if you're following your syllabus, you don't have to write that down. If you want to write that down, it is okay too, whichever you prefer. Okay, let's keep going. Now we're going to get into problems that are a little more complicated, okay? We're going to do problems with more than one person or car. These are harder, but we're just going to think of all the steps, put them all together, and it'll make more sense. Okay, Isaac and Ethan. I'm just going to write them down. Isaac and Ethan were driving out to Pittsburgh. Okay, so let's kind of draw what we're doing here. From Philadelphia, okay, to Pittsburgh. Okay. So let me just read the thing. Isaac and Ethan were driving out to Pittsburgh. Isaac took the PA Turnpike and averaged 50 miles per hour, while Ethan took the scenic route scenic route 30 and averaged 10 miles per hour less than Isaac. If they both left at 10 a.m. and Isaac arrived at his grandparents' home at 4 p.m., when did Ethan arrive? Don't let problems like this frighten you. Yes, there's a lot of information, but let's break it down. We know that the distance of Isaac and the distance of Ethan are the same, right? They're both going from Philadelphia to Pittsburgh. Okay. We know that distance is rate times times, all right? So what do we know? What are we being given in the problem? Okay, that's why we're setting this all up. Because I know that the distance of Isaac is equal to the rate of Isaac times the time of Isaac. And it can be written like this. And the distance of Ethan is equal to the rate of Ethan times the time of Ethan. Okay, so what do I know? All right, so I know that Isaac's time is 6 hours because they both left at 10 a.m. and it said Isaac arrived at his grandparents at 4, and from 10 to 4 is 6 hours, right? So Isaac's time is 6 hours. Okay. They also tell us that Isaac took the PA Turnpike and averaged 50 miles per hour. So his rate is 50 miles per hour. Okay. So the time of Isaac is 6 hours. The rate of Isaac is 50 miles per hour. What do we know about Ethan? All right. We don't know when Ethan arrived. Okay. So, that is what we're looking for, right? But we do know that his rate was 10 miles per hour less than Ethan. So if Ethan's is 50, 50 minus 10 is 40, right? So that means that the rate of Ethan is 40 miles per hour. Okay. So how do we put this all together, right? We know that the distance is the same. They're equal. The distance of Isaac is equal to the distance of Ethan. And the distance of Isaac is rate times time. And the distance of Ethan is the rate of Ethan times the time of Ethan. So hopefully this is making sense what I'm doing here. So what do we know? We know that the rate of Isaac, we already figured that out, is 50 miles per hour times the time of Isaac, 6 hours, is equal to the rate of Ethan, 40 miles per hour, times the time of Ethan. But that's what we don't know. That's what it's asking us. It's asking us how long did it take, or when did Ethan arrive? Sorry, when did Ethan arrive? We don't know, right? That is our unknown, so we just keep that as the time of Ethan. Well, now we can just do some math here, right? Because 50 times 6, well, let me get back to my notes here. So 50 times 6 is 300, okay? Is equal to 40 TE, right? We don't know the time of TE, but we know how to solve this because now we can divide by both sides by 40, and the time of Ethan then is 7.5, okay? 7.5. So we know now the time of Ethan is 7.5 hours. But again, what is the question asking us? It's asking us, when did he arrive, right? It's not asking us how long it took him to get there. It says, when did he arrive? And so they left, what time did they leave? They left at 10 a.m. And so if it took him 7.5 hours, then when we do the math, we figure out that he arrived at the grandparents' house at 5:30 p.m. And that is the answer to this problem, okay? So again, a lot of information, a lot going on here, but break it down step by step and it'll make more sense. Okay, we are gonna go through 2 more examples like this. And then if you need more, when you look at the teacher's manual, there are some practice problems. Give me just a second here. There are, I believe, 4 practice problems, okay? that you guys can go through. I'm not going to go through all of those today in this recording, but if you feel like you don't have a good handle after I go through the next 2 examples, then go ahead and look at those practice problems and work through them and figure it out. And remember, if you ever get stuck on something while you're working through your homework, please reach out to me and I'll record another video like this to help you work through it. Okay. All right, so we have 2 more problems we're going to do. All right. Hopefully it'll make more sense now that we're into the more complicated problems. Wesley and Derek. So now I'm doing example 5. Wesley and Derek walked the long way to work. Okay, so they're going from home to work, right? We have Wesley, so I'm just going to put a W for Wesley and a D for Derek. Wesley walked at 4 miles per hour and Derek walked at 6 miles per hour. Derek arrived 1 hour sooner than Wesley, so how far is it to work? Okay, we know that their distance is the same, right? They both are walking from home to work, and so the distance is the same. Because the distance is the same, we're going to set it up like we did the last problem. But before I can do that, we know that the distance of Wesley is the rate of Wesley times the time of Wesley, and the distance of Derek is the rate of Derek times the time of Derek. What do we know? What did they give us? Wesley walked 4 miles per hour. So the rate of Wesley is 4 miles per hour. Derek walked at 6 miles per hour. So the rate of Derek is 6 miles per hour. Derek arrived 1 hour sooner than Wesley. We don't know what time that, it doesn't tell us like what time they left or anything, but the only thing that we do know is that we don't know the time of Derek, right? Okay, so that's going to stay TD. But we know that the time of Wesley is equal to the time of Derek plus 1, because Derek got there an hour sooner. Okay, so whatever Derek's time is, Wesley's is, we're going to add an hour to it. Okay, and this is how we do that. So now I'm going to set them up. My distance is equal. When we are dealing with problems where the distance is equal, okay, then we set them equal to each other. All right, so how do I do that? So I say, okay, the distance of Wesley, or the is rate times time. His rate is 4 miles per hour. And his time is the time of Derek plus 1. Sorry, my marker there kind of messed it up. There we go. Is equal to, because their distances are the same. So now I have to look at the distance of Derek. He's at 6 miles per hour. And times TD, the time of Derek, because we don't know the time of Derek, right? Okay. So what do I do here? Well, over here, just like if we were, let's say, looking at this as an algebra problem and we had to say 4 times x plus 1, okay? We have to distribute, right? We have to multiply the 4 times the x and the 4 times the 1. We're gonna do the same thing here. We're gonna multiply the 4 times the TD and the 4 times 4. And when we do that, we will have 4 TD plus 4. And over here, we have 6 times TD, which is 6 TD. Now we're like any other 2-step equation where we have to get all of our variables on one side. TD is our variable in this case, and all of our units on the other side. Normally, I would pull my variables to the left, but I'm not going to do that in this case because if I have to subtract 6 here, I'll be left with negative, and I don't want to deal with negative numbers. So I am going to move the 4TD over to the right side of the equation. And when I do that, it cancels over here. I'm left with 4, and 6 minus 4 is 2TD. Now, in order to get TD by itself, I divide both sides by 2, and I find out that the time of Derek is 2, okay? Or 2 hours, right? Okay, let's go back to our equation though, because now I have figured it out. What are they asking us though? How far is it to work? Okay, so I now know that TD is 2 hours, right? They don't ask us the time of Wesley, but I now know that it's 3 hours because it took him 1 more hour to get there. But what they're asking for is distance, right? And distance is rate times times. I'll come over here. Hopefully there's not too much of a glare on the screen and you can see that. Yes. So I can take either one. I can take Wesley or Derek and get the same answer. So we'll just say, okay, Wesley's rate was 4 and his time is 3. So it's 12. It's 12 miles from home to work. I could do the same thing here. I could use Derek and do 6 times 2, which is still 12 hours, right? So in this case, it didn't matter. Once we know rate and time, it doesn't matter which one we use to tell us the distance. So just be sure to look at what they're asking, because they could have asked us what was Derek's time. They could have asked us what was Wesley's time, but they asked us what was the distance. So now we know that the distance from home to work is 12 miles. Okay, hopefully that makes sense. All right, let's do one more example. Okay. Johnny left on his bike at 9 a.m., speeding along at 6 miles per hour. Joseph left at 10 a.m. and caught him at the park at noon. How fast was Joseph traveling? Okay. Because we have Joseph and Johnny, your book has chosen to use, and I find this confusing, so bear with me. They're using F for Joseph and N for Johnny. Okay, so that's the first thing, is when we're tackling these problems, we come up with a variable to use for each of our people. And they are traveling from home to the park, right? Okay, so the distance of Joseph is going to be the same as the distance of Johnny, right? Okay, let's go over here. So the distance of Johnny is equal to the rate of Johnny times the time of Johnny. It's so hard for me not to write J. And the distance of Joseph is equal to the rate of Joseph times the time of Joseph. What have they told us? They told us that Johnny left at 9 a.m. and he got to the park at noon, because it says that Joseph caught him at the park at noon, so he caught up to him. So we know that Johnny's rate is 6 miles per hour and his time is 3 hours, because if he left at 9 a.m. and got there at noon, that's 3 hours. Okay, what about Joseph? It tells us that Joseph, how fast was Joseph traveling? We don't know. Okay, that's what it's asking us. But we know that his time is 2 hours because he left at 10 a.m. and got there at noon. Okay. All right, so now that we have our variables set up and everything we know, how do we set up the problem? Remember, their distance is the same, so I set them equal to each other. So if I look at Johnny, I have 6 miles per hour, I meant to do it this way, times 3 hours is equal to the rate of Joseph times 2 hours. Okay, now it's really easy. 3 times 6 is 18, right? Is equal to 2RF. I just had to multiply RF times 2. And now I divide both sides by 2, and the rate of Joseph is 9 miles per hour, okay? And I believe that is what the question asked us, is how far did they travel? Oh, okay, it asked us how fast was Joseph traveling, 9 miles per hour, but then it also asks us distance, how far did they travel? Again, I can take either 6 times 3 is 18, 9 times 2 is 18, because remember, distance is rate times time. So they traveled 18 miles from home to the park on their bikes. It doesn't matter if we use Johnny or Joseph. Hopefully this makes sense. Again, there are practice problems. There's 4 of them. If you want to do more of these, but remember to start with writing out everything you know. Make a diagram, write what's given, and then be sure to look at what they're asking you for. I hope this is helpful and you have a great day.